AP Calculus AB, Unit 9 review, corrective. So we're going to go over the corrective to help you get ready for the retest. So I guess first we could just look at the answers. So let's see. Here are the answers. So pause the video. You need to. And you can check the top half. Almost get them all. Okay, and the bottom half. Check your answers. Okay. All right, so, and I'm also going to add just a few comments about some problems that aren't really represented on here that were on your test, that could be on your retest, just a couple of issues that might make a difference. So, and I'll try and talk about, mistakes, common mistakes I saw as we were taking the test. So these first ones, you just got to be careful. It seemed like most people knew how to do these, but we're making little mistakes. I personally like to draw a picture just to kind of organize the information because it's easy to mess up. So we're going to do, this time we're using all the values. So in the test, I think the first one you had to use like 3 subintervals or whatever. So in that case, we didn't use them all. I'm doing right in endpoint. So we're going to use them all. And, we could put the heights on here, 4, 8, 5, 4, and 9. Now it's a right-in endpoint, so we're always using the right side, so we're not going to use this one, but this is going to be the height of the first one. This will be the height of the next one, next one, next one. So I'm just trying to make sure I'm looking at the right value here. Okay. These down here are changing this time. And some of you guys had the wrong values for these. And so the estimate 1 to 10 of f of x dx is approximately, so it's appropriate to use a symbol here, and it's going to be base times height, 2 times 8, 3 times 5, 2 times 4, and 2 times 9. So that's going to be 16, 15, 8, 18. Some of you guys then just added them up wrong, the final total. So just be careful. So I got 31, 39, 47, 57. Show work on paper if you have to. Do vertical addition. Who cares? Just, no shame in that. Get the right answer. It's best. Next one, we're doing the same value. So I'm just going to redraw this real quick. Okay, but this time we're going to connect the endpoints. These are the height of these trapezoids. And hopefully you have no problem remembering how to calculate the area of a trapezoid. It's really a rectangle, base times height, but there's 2 bases, so it's the average of the bases. So it's the average of the bases, 4 plus 8 divided by 2 times the height. Average of the bases, 8 plus 5 divided by 2 times the height. 5 plus 4 divided by 2 times the height. And 4 plus 9 divided by 2 times the height. Now these ones that are multiplied by 2 is cleaned up real nice. This one looks a little messy, but we're going to have 12 plus 3 times 13, so that's 39 halves, plus 9 plus 13. We could change this to 19 and a half, or you could change all of these to fractions. I feel like it's a little easier to just do that this time. So Our final answer, 1 to 10, f of x dx is approximately 28, 30, 40, 53 and a half, or 107 over 2. Either way. Okay. All right. Next ones are definite integrals. So these, you're just these first two don't have absolute values. So we're just trying to integrate. Now here, I'd rewrite this as x to the negative 1/2, 3x to the first plus x to the negative 1/2. You cannot integrate this and multiply them together. That's not possible. You need to either use u substitution, which I don't think is going to work here, or clean this up, simplify it, get it as, multiply it out. So we have 3x to the positive 1/2 plus x to the negative 1. Rules of exponents, you add the exponents. So now we can integrate it. Bump it up 1, divide by the new exponent. Bump it up 1. Oh, no. Watch out. If you bump this one up 1, divide by the new exponent, that's not good. So this is actually 1 over x. So this is now natural log of the absolute value of x. You need the absolute values there. I know they're going to eventually go away, but they should be in your work. Okay, so now we got 2, 4 to the 1/2 is 2 cubed is 8. Natural log of the absolute value of 4 minus 2 plus natural log of the absolute value of 1. Now, absolute value of 1 is 1, natural log of 1 is 0. So we have an 8 minus 2 is 6 plus natural log of 4. We should get rid of the absolute values by this point because the absolute value of 4 is 4. So that's how you do it. We could have trig. You guys should be good with trig. A lot of you guys are getting bad trig values. First of all, you need to know how to integrate these without the formulas anymore. So this is a u substitution opportunity. I think you could pull it off without u substitution too, because I know an extra 2 is going to pop out that I don't want, so I'm just going to put 1/2 in front. So, I could jump down here and I could say, okay, all right, this is going to be 6x squared over 2. Antiderivative cosine is sine 2x. And then I know there's going to be an extra 2 that pops out in front that I don't want, so I put the 1/2 there. And then I start integrating. So I could do that. I could do that in my head directly. If you feel comfortable with that simple u substitution, simple chain rule issue, and it's just extra number. Otherwise, this will give you that 1/2 too, but it's going to involve some extra steps of work. Now, when you do the u substitution, this should not involve the u substitution. You could make it happen, but it's going to be hard, and you're probably going to mess it up. This guy, we should just integrate on its own. It doesn't need anything special. We can integrate term by term. Okay, now this is the one that has the 1/2. And now it's going to be cosine u du. All right, so then the antiderivative of this is 6x squared over 2. And then the antiderivative of this is going to be 1/2 sine u. Now these are and then you want to change it back to x, so then you do that, and then you want to do 0 to pi over 2. So you can do that. Now they're both going to have the same limit, so I kind of jumped down here and just did it all at once, but these could be separate, which is more like what we get right here. Now, so this is going to be 3 times pi over 2 squared. It's going to be pi squared over 4. The pi gets squared, minus 3 times 0, plus 1/2 sine times pi minus 1/2 sine times 0. Now sine of 0 is 0. Sine of pi is actually 0. Your final answer is 3 pi squared over 4. Don't lose the squared on the 4. Just know your trig. And if you have reciprocal trig like secant of pi over 3, well, you need to know that's 1 over cosine of pi over 3. And then you need to know your cosine pi over 3 value. So forth. That's just a little side note. Okay, now these are absolute values. If you don't do anything, if you just pretend like those are parentheses, you're probably not going to get any credit. So these are the ones where we have to break up. Now this is a problem we could do 3 different ways because it's a linear absolute value. So we could graph it because it's very linear, and when you graph it, it's going to create shapes like triangles and stuff that we could calculate geometrically. So we could do it that way. 1, 2, 3, 4, 5, 6. So it's at -6. Its slope is 3. So it's going to go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. And then it's going to keep going up. So, I mean, you want to know what the height of this is going to be. Now, instead of relying on your graph, just rely on your knowledge of the slope. Now, this has to get flipped up here because it's an absolute value. So this is your actual absolute value graph, right? So you got to find this area. So that's going to be 1/2 base times height. And then the other one's 1/2. The base of this one's 4, and the height, if it goes up 3 for every one you go over, then it goes up 3, 6, 9, 12. The height of this is for sure 12. So that's going to give you 6 plus 24 is 30. So you could do it that way, which seems like a nice, nice way to do it. But be careful. The other way is to either use a table or kind of do. So we could find the zeros by setting equal 0, factoring, and we could do a line check. Now, the line check is more useful for the table. You might be able to get away without a line check, unless there's trig involved, then you definitely want to use line check still. But test x equals 3 is positive, negative. So we got to break it up 2, and this part's going to be negative, so we've got to fix it. So what we're going to do is we're going to say, all right, 0 to 2 of 3x minus 6, no absolute values anymore. You just got rid of them. That was the point of it. Plus 2 to 6 of 3x minus 6 dx. Okay. And then this is the negative part, so you got to fix it with an extra negative in front to make sure it comes out positive. And then you say, all right, negative 3x squared over 2 minus 6x, 0 to 2, 3x squared over 2 minus 6x, 2 to 6. And then we get negative. You plug 2 in there, and you get 6 minus 12. Minus plug 0 in is 0 minus 0. Plus, you plug 6 in. 36 over 2 is 18. Times 3 is 54. And then plug 2 in, and you get 6 minus 12. So then that's negative 6, and this negative fixes it, makes it positive 6, which, by the way, is the area of that first little triangle, right? And then this one's going to be 54 minus 36, which is 18 plus 6 is 24, and that gives you the area of the other triangle that we got, and you get 30. So you could do that, or you could do a table, which is the same work, but just consolidate a little bit. There's a little bit of repetitious work in here. 0 to 2, 3x minus 6 dx. Okay, so we're just going to drop the absolute values, do 3x squared over 2 minus 6x plus c. Don't need the c in this case. 0 to 6 are the values that we're going to plug in. So you plug 0 in, and you get 0. You plug 2 in, and you get 6 minus 12 is negative 6. And then you plug 6 in, and you get 36 over 2 is 18. You get 54 minus 36 is 18. And then you find the distance between these, positive 6, positive 24, and you add them together, and you get the answer. So it's kind of a nice way to streamline the same. You're doing the same work as you did here, but you're just not doing it redundantly, and then it's also kind of organized in a little nicer way. Okay, 7 we can't do geometrically because it's not going to give you nice geometric shapes. You can't use graph on that. So we could find the zeros. Okay, and do a quick line check. Doing the table, you could probably avoid the line check here. If it involved trig and rational numbers, I would definitely use the line check though. So positive, negative, positive. So we could say, all right, well, we're going to do 0 to 3 of 2x minus 6x dx, and then we're going to do 3 to 6, 2x minus 6x dx. And the first part's the one we got to fix, and that one's fine. So we're going to find the antiderivatives. We're going to be negative. It's going to be x squared, 2x squared over 2, so it's x squared minus 3, oops, that was supposed to have a squared there. So it's going to be 2x cubed over 3 minus 3x squared. 2x cubed over 3 minus 3x squared. And then we'll plug the values in. So if you plug 3 in here, that's gonna be 18 minus 27. Plug 0 in, it's gonna be 0 minus 0. Plug 6 in, it's gonna be 36 times 2 is 72. 144 minus 3 times 36 is 108. Minus, if you plug 3 in here, it's going to be 2 times 9 is 18 minus 27. So you just got to be careful. So this is going to be negative 9, but then it gets fixed and it's positive 9. So that's the area of the first chunk. This is going to be 36 minus negative 9. So that's going to be 45. And the final answer is going to be 54. Or you could do a table. So the table, you could say, all right, 2x squared minus 6x dx is going to be 2x cubed over 3 minus 3x squared plus c. Plug 0 in it, 3 and 6. If you plug 0 in, you get 0. Plug 3 in, you get 18 minus 27 is negative 9. You plug 6 in, this is kind of a big one, 36. 72, 144 minus 108 is 36. Find the distance between these, add it up, same answer. So table is nice as long as you know how to use it. Okay, so you got to be ready for integrating absolute values. So let's do this one. This one just says to like essentially set it up, but let's try and find the answer. So this is one where we'd want to find the zeros, set it equals 0 and solve it. So alpha equals pi, when does sine equal 1/2? Pi over 6, quadrants 1 and quadrant 2. So we get x equals pi over 6 plus 2 pi k, infinite answers, and x equals 5 pi over 6 plus 2 pi k. And then you want to do a line check, and we're only concerned with 0 to pi over 2, right? So pi over 6 is the only one we actually care about. So we can test a value, I test 0. Plug it in here. Sine 0, 0, it's going to be negative. Negative, positive. Okay? So then we could rewrite it. We could say, okay, well, 0 to pi over 6, 2 sine x minus 1, drop the absolute values, put parentheses, plus pi over 6 to pi over 2, 2 sine x minus 1 dx, and then we got to fix this one. We put a negative. So that's the setup of it. You could also do the table instead, but if we're gonna, let's see if we can finish this by hand because you guys had a lot of you guys have trouble on something like this, just getting basic trig value. So this is gonna be antiderivative of sine is negative 2 cosine x minus x. Negative 2 cosine x. minus x. Just think, if you take derivative of this, you should get back what you had. If derivative cosine gives you negative sign, which we don't want, so we need that extra negative. Okay, so it's going to be negative, negative 2. Cosine of pi over 6 is root 3 over 2 minus pi over 6. Minus cosine of 0 is 1. Don't just assume it's 0. And then cosine of pi over 2 is actually 0. And cosine pi over 6 is root 3 over 2. So we just got to carefully do this. So that goes away. That goes away. We got to distribute this negative in here. The 2's cancel, so we get positive root 3 plus pi over 6. You should get a positive answer from all of this. Oh, there's a plus 2, so it's going to be minus 2. That should be positive, but that's kind of hard to, let's put a little bit of work into it. Estimate without a calculator. Okay, this will be minus pi over 2 plus 2 root 3, no, plus root 3, and then plus pi over 6. Now, I want to simplify this. So we're going to say it's 2 root 3 minus 2, and then least common denominator would be 3. So that's positive 2 pi over 6 minus 3 pi over 6 is going to be minus pi over 6. I believe that's right. I didn't put that on my answers, but anyways, just be careful with that work. Okay, here we have graph. Now this is a little different than what was on the test, but it uses an idea. This is the graph of the function. And so if you want to integrate it from 0 to 5, you're just finding this area right here. So this area, 1/2 base times height would be 2. This area, base times height, would be 6. This is a quarter of a circle, so it's going to be 1/4 of pi. The radius is 2 squared, so that's going to end up being pi. And then this is also going to be pi, but it's going to be negative. It's below here. So the first answer is going to be 8 plus pi. Oh, wait, no. Sorry, 6 plus pi, because it's just 0. It's just this part. Okay. Next one, if we go from -1 all the way to 7, but it's going to be the absolute value, so it's going to force any negative parts to be positive. So it's going to be 2 plus 6 plus pi plus pi. So it's going to be 8 plus 2 pi. Did I make a mistake? Or are my answers wrong? Oh, tricky. This is -2. -1 would be right here. So this is actually like a trapezoid. So that area is going to be average of the base is 1 plus 2 over 2 times the height is 1. So it's going to be 3/2 or 1.5. So it's going to be 7.5. I even tricked myself. All right. Okay. Next ones. So distance and displacement. Distance is the integral of speed, the absolute value of velocity. And displacement is just the integral of velocity. But we got to find velocity first. This is acceleration. Some of you guys just put this into this as if it were velocity, but we got to find the velocity equation. So velocity is the integral of acceleration is the integral of 2t minus 6 is 2t squared over 2 minus 6t plus c. You need to find the c value. You have an initial condition for velocity. So V0 equals 0 squared minus 6 times 0 plus c should come out to 8. Those go away, c equals 8. So your velocity equation is t squared minus 6t plus 8. Now you could find the position equation, but you don't really need to for what we're doing right now. You could, and we're going to kind of do it, but the main thing is you could avoid a little extra work. So we could, you know, to me, using a table to do both of these at the same time is the best plan. So we got to find the zeros. Got to factor this correctly. So zeros are at 2 and 4. We do a line check. If you test a value x equal or t equals 5, positive, negative, positive. Okay. So the table, we can use one table to do both of these. We're going to integrate velocity, like we have to integrate velocity, right? For both of these. So we got to integrate t squared minus 6t plus 8. So that's going to be t cubed over 3 minus 6t squared over 2 plus 8t plus c. I'm going to put, we're doing it from 0 to 3. So 0, 2, 3. 4 we don't need to worry about. Just doing 0 to 3. So we plug 0 in here, you get 0. Now, if you found the position equation, I think you'd actually get a 1 here, but then that one would, all of these would have an extra 1. And in the end, it wouldn't change your answer. Plug 2 in, that's 8 thirds minus 12 plus 16. So that's positive 4. Least common denominator, that's 12 thirds. So this is 20 thirds, or 6 and 2 thirds. Or did I make a mistake? I feel like it's right. Maybe I have the wrong answer on my. It's possible. Okay. Well, can you spot my mistake? It's right here on my work. I got 5 for some reason, but oh no, we're good. On my work, I did it. We're gonna get the same answer. That's my work. You plug 3 in. It's gonna be 9 minus 27 plus 24. 3. That's gonna be 6. So the distance between these is 6 and 2 thirds. The distance between these is 2 thirds. Displacement is just the final spot minus the initial one, and it could be negative. So I just get positive 6 for that. Now distance is going to be these added up. 6 and 2 thirds plus 2 thirds is 7 and 1 third. So you could do it all at once. Or you could do these like the previous absolute value problems where we don't use the table and we just do all the workout. But then I think you kind of probably are going to do each one on its own. Okay, mean value theorem. This is the average value of f. The basic idea is that if you want the average value of a curve from here to here, then that's the average height of it. So what we do is we find the area under it and we smooth it out into a rectangle, and the height of the rectangle is what we're looking for. So if we just find the area under the curve, it's going to be the same area as the rectangle. Smooth it out and then divide by the base of the rectangle to get the height. So that's the way I think it through every time. If you try and memorize this, just straight up memorize it, you will mess it up. Eventually. Maybe you might pull it off for this retest, but then when it pops up randomly in the middle of the AP test, you're going to mess them up. Thinking it through, understanding where it comes from, it's a pretty simple idea, much more effective. So F average is going to be 1 over 6 minus 3, 3 to 6, x squared plus 2, need parentheses, because there's multiple terms inside the integral, So the antiderivative is going to be x cubed over 3 plus 2x. Don't need to write the plus c, it's a definite integral. So we plug 6 in. It's going to be 3672 plus 12 minus, you plug 3 in, you're going to get 9 minus 6. So that's going to be 84 minus 3 is 81. Wait, did I make a mistake? Why did I put a minus here? It's plus 15. All right, so what's it going to be? It's going to be 69 instead. And then don't forget this. So you forgot that. Final answer is 23. Okay? Now, the x stars, or the c values that are guaranteed by the mean value theorem, are the places where the actual function equals the average function, the average value. And it's guaranteed to happen at least one time on this interval. Don't give any answers outside this interval. Show them in your work algebraically. They might show up. Okay. So f of x is x squared plus 2 equals 23. So I think the way I'm going to do it this time is just subtract 2 from both sides and take square root of both sides, plus or minus. Now, I want to see plus or minus in your work, okay? Some of you guys just didn't do that, and I took off points. But then a lot of you put these in your final answer, but it really should just be the ones that are between 3 and 4. And square root of 21 is between 16 and 25, so it's like 4.5 or something like that. So that's good, but the negative one isn't this time. Next time it could be the negative, and you throw out the positive. But make sure you don't give. Now, if you get no answers, that shouldn't happen. That probably means you made a mistake somewhere, because you're guaranteed to get at least one. All right, fundamental theorem of calculus with the graph of the derivative. So I want you guys to show the setup for this. So what we're doing here is we're saying, okay, well, we can integrate f prime. We have the right information. We're going to go from 3 to 9. What we know and what we want, but smallest to biggest, either way. And so what we know is fundamental theorem of calculus part 1 says, well, if you integrate a derivative, they undo each other, and you just give the original function. And then you plug in the limits, right? I mean, we could put an in-between step here where we say it, where we show it like this, right? And that's what's happening. And I'm just jumping to it here. Now, I want this, so then I'm going to rewrite this with that by itself, which means I got to add this to the other side. Try not to set this up biggest to smallest, because someone did that, and you could pull it off that way, but then you got to interpret your area from a graph as negative because you're going backwards. And I think it's just more likely you'll forget. So f of 3 is 10. Now this is the area from 3 to 9. So it's all this area right here. So it's going to be 2 triangles, 1/2 base times height. So 1/2 base times height, 1/2. You know, so to help me out and help you, like show some work and then maybe kind of show what you got on the picture so I can figure out. So it's going to be 6, and so your answer is going to be 16. Okay, next one. I'm going to start the same way. I'm going to say, all right, well, let's integrate f prime of x. And let's go from 1 to 9. And it's going to be f of 9 minus f of 1. And I want f of 1. So this time I'm going to add this over here and subtract this to get f of 1 by itself. Now f of 9 is negative 7. So I got to figure out from 1 to 9. Well, that just adds this rectangle, 2 times 2. Be careful, the size of the marks on the vertical axis and horizontal axis are different. So this is going to be 4. So it's going to be 10, and the final answer is going to be negative 17. Fundamental theorem of calculus part 2. These are quick and easy, and you should get 100% on them. what we do is we say this undoes that, but then we got to plug limits in. So sine of 6, sine of x cubed, but then there's the chain rule issue that we haven't taken derivative of what's inside yet, the inner function. So we got to take the derivative of what's inside, chain rule. The derivative number is 0, but only what you plugged in. Okay, so your final answer here is negative 3x squared sine x cubed. Okay, this one, same deal. So this one's going to be sine of parentheses x cubed. I like putting parentheses first because we're going to multiply by the derivative of only what you plugged in. And some people might accidentally do the derivative of x is 6th. That's not right. Now, when you take derivative of e to the 4x, it's e to the 4x, but it has its own little chain rule and gives you another 4. So your final answer is going to be 3x squared sine of x to the 6th. I do want you to simplify these. Minus 4e to the 4x sine of e to the 8x. Okay, next one. Integral of sine of 5 squared, but the derivative of 5 is 0, minus. Now, when this happens, a lot of times people forget the minus on the next term. Still minus sine of x cubed squared. So the derivative, just what you plugged in, x cubed is 3x squared. So final answer is negative 3x squared sine of x to the 6th. Okay, next one. So I was trying to leave room for it. So final answer is 2x square root of 1 plus x to the 6th minus 2e to the 2x square root of 1 plus e to the 6x. So I think those, hopefully get those 100% right. Of all the problems on here, they're kind of some of the most direct. Now here's just some other fun stuff to throw in there. F of x is odd. What is an odd function? Well, like a cubic, or, and you could draw a picture. Say, okay, well, you could do a cubic, or like a sine curve is an odd curve. They have symmetry across the origin, x and y axes. Now, if 0 to 2 is 5, then what's negative 2 to 2 going to be? Well, it's going to be, it's symmetric. It has the same shape, but it's going to be negative because it's below the x-axis. And you're going to get negative 5 plus 5 is 0. You can cancel each other out. Now, if you take the absolute value, you're going to force the negative part to be positive, and you're going to get 5 plus 5 is 10. Okay. Now, this next one, we actually had problems like this on the test, and we've had these on previous tests. And these should be quick 100%, but tons of people lost points on here. Now, the way I would do this is there's this property of definite integrals that says if the bottom of one limit matches the top of the other and they have the same thing inside, then you pretty much connect them together and you add them. So that means what we get is we get 2 to 5. Whatever's on the bottom here needs to be bottom. Top here, 2 to 5. F of x dx equals 6 plus 2 is 8. So the answer here is 8. Now, a lot of times I put a little extra number in here. You just multiply it. If there's a 3 here, it'd be 24. Like this one. Now, this one, you want to break this up. And I would take the time to just write it this way first. Plus, you have to integrate the 7. It's inside the integral. Okay? It doesn't get the 6, though. The 6 is only multiplying the f of x. The 6 isn't outside the brackets. So this is going to be, now watch out for these limits getting flipped upside down or whatever. But this is going to be the 8 that we got. And then you could integrate this. You could say, all right, well, that's going to be 7x, 2 to 5, top first, 35 minus 14 is 21. Or you could think of this as a flat line value 7 and you're integrating the area under it from 2 to 5, well, it's just going to be a rectangle. It's going to be 3 times 7 is 21. So either way, you're going to get 21. So we're going to have 48 plus 21 equals 69. You guys should be good at those. And this is not the first test we've had them on. Now, I want to add just a couple other notes because this doesn't, there's a couple problems that weren't represented. Now, there was one, let's see, I have a blank piece of paper. So let's do a couple extra problems that were like ones on your test, but weren't on this corrective. So one problem I want to do, let's see. So there, problem 11, you may have had one like this, but the problem looks like this. Or something like it, but this will be a good review. And they give you a piecewise function. And so this is problem 11. I'm going to just do the whole problem, part A and B, because it has a bunch of good stuff in it. So here's the deal. This function right here is y equals x to the fourth. This function right here is y equals negative 2x plus 20. There's two ways we could find this area in here. Okay, one was vertical slicing. Okay, but then you break it up here. And then you have to do a vertical slice here, vertical slice here. You do y top minus y bottom, y top minus y bottom. And you'd find these two separate areas, and then you add them together. You could also find this as a triangle if you want. But the area, you're going to have to do 0 to 2 of x to the fourth dx on its own, plus 2 to, now we got to find this x-intercept. So we're going to set this equals 0, and we get x equals 10. So this is at 10 comma 0. Some people just said 20. No, this is the y-intercept. You can find the x-intercept from it. You got to put parentheses around this, 2x plus 20. So that's your setup. And then x to the fifth over 5. X squared over 2, 20x. And so it's going to be 32 over 5 plus negative 100 plus 200 minus negative 4 plus 40. So that's going to be positive 100 minus 36. So that's going to be 64. So we could either give a least common denominator and say that it's 320, 352 over 5, or you could change this to 6 2/5, and then that would be 70 2/5, or 70.4. Okay, so that's, now alternatively, and some of you, there's some benefits to this. You could have done a horizontal slice. By the way, we're going to be doing a lot more of that. We're going to have to do that. And it'd be x right minus x left. So if you do it that way, the limits are going to go 0 to 16 because we're slicing vertically. And there's only one chunk. We don't have to break it up in two chunks like this because x right's the same and x left's the same. Now, we got to get this x in terms of y. So you got to solve this x for y. So it's going to be y minus 20 divided by negative 2. And you could write that different ways. And this one's going to be plus or minus the square root of y, the fourth root of y. Now, it's the positive one this time because it's the right half of that quartic. So you got to do x right. So it's going to be negative 1/2 y plus 10 minus the fourth root of y. Okay, so then it's going to be negative 1/2 y squared over 2 plus 10y minus y. This is y to the 1/4, so it's going to be y to the 5/4 divided by the new exponent. 0 to 16. So if you plug 16 in, 16 times 16, but let's do 16 divided by 4 first. Let's do 4 times 16 is 64. So negative 64 plus 160 minus the 4 through to 16 is 2. To the 5th is 32. 64. 128 over 5. And then you plug 0 in and you get 0 plus 0 minus 0. So this is going to be 96. And this is 25 3/5. So that would give you 70 2/5. Same answer. Okay, so either way. Now part B, this is where a lot of people struggle. Part B says find all the values of x star guaranteed by mean value theorem. So they're not asking for the mean value, but you need to find the mean value to find these guaranteed places. So the mean value should be somewhere between 0 and 16 to make sense. It's the average height of this whole curve. Now to find it, this is where a lot of people messed up. They found the average value of this chunk and average value of this chunk and add them together. Well, that's not going to give you the right value. And you can't even just average them. So you have to say, no, we're going to find the area under the whole curve 0 to 10 of f of x dx. And then we're going to divide it by the whole base of the rectangle, the smoothed out region. This is the setup. Now, the good news is you've already found this value right here, up here. It's 70 2/5, or, I don't know, there's different ways. So 70.4, and you could say, okay, well, you could say it's 7.04, divide by 10, or 7 4/100, or 7 1/25. Or we could just write as one nice fraction instead. So 7, that'd be what, 176 over 25? That might be easier to work with to do math, but that's your average value. Now the x star values, here's the deal. If you look at this, 7.04 is kind of like somewhere in the middle here. And we know we should get at least one answer because the mean value theorem guarantees it. But looking at this picture, we expect to get 2. We get one here when this line crosses this curve, and one here when this line crosses this curve. You got to find those each separately by setting 176 over 25 equal to x to the 4th, and then separately setting 176 over 25 equal to negative 2x plus 20. And you got to solve each of them separately. This one, we're going to take the 4th root of both sides, plus or minus. If you don't write plus or minus, I'm taking off points. Now, I'm fine. We only want answers that are between, first of all, we want answers between 0 and 10, but specifically, this one should be between 0 and 2. So hopefully this is 2. But the negative one for sure is going to go away. Now, you could try and simplify this. I'm fine with you leaving it like this. It actually kind of, you could do a bit of work on it, but this is fine. But I should see the plus or minus in the work. Now, this one right here, you can multiply everything by 25. And we get 176 equals negative 50x plus 500. And then keep solving. So that's going to be 324. And this answer should be between 2 and 10 for sure, positive 2 and 10. So if you don't get that, something's wrong. So 324 50. I mean, you could simplify 162 over 25. Either way. But that's how you do it. So that was 11. That was definitely a hard problem. And let's take a look at 15. 15 was this challenging problem, and I asked you to set it up two different ways. Okay, and you might have had one like this or something similar. So I'm just redrawing the picture. Now, one of the big challenges was you had to find these intersections here. And your version might have been challenging. This one's challenging, so I got to remind you guys of some algebra skills that we practiced first semester that maybe it's been a while. But to find these intersections, you'd set these equal to each other. Okay? Should most people thought of doing that. And then you probably want to move everything to one side. And this is where some people did some weird stuff. Like some people said they still had a plus 22 here, but that should be minus. So, and then some people started factoring this or putting it in the quadratic formula. This is not quadratic. This is a sixth degree polynomial. The quadratic formula doesn't make any sense on it. Regular factoring of quadratic trinomials doesn't make sense. You're kind of stuck here. So we need to use the rational root theorem, which I'm sure you're all excited about, but you got to keep this in mind. It could come up anytime on your AP test in my class. Rational root theorem said we're going to look for a list of P over Q, and P is from the last term and Q is from the first coefficient. It's all the possible factors. So plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 11 over 1, plus or minus 22 over 1. This is the exhaustive list right here. We got lucky because there's a 1 in front, otherwise it'd be a much longer list. And there's no fractions, so that's nice. Now you want to check these until you find a 0, confirm that you have a 0, but I would just do it in my head. Plug them into this, and they should give you 0. If they don't, they're not 0. So if I plug 1 in, you get negative 20. No, that doesn't work. So 1 doesn't work. Negative 1. If I plug negative 1 in, I get positive 1. Plus 21 is 22. Minus 22 is 0. So negative 1 is one of the zeros. Now, by the way, there's another one. If you kept going, I think positive 2 works. But negative 1 is good enough for us. So then we use synthetic division. So we're going to take negative 1 out. And then we're going to list all the coefficients. If there's any missing, you go put 0. So x to the 5th, x to the 4th, x to the 3rd, x squared. So you got to remember how to do synthetic division. Drop the first term down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. You should get a 0 at the end if you pick the correct one, okay? What this gives you is x minus 1, and then you have x to the 5th minus x to the 4th plus x cubed minus x squared plus x to the 1st minus 22 equals 0. So we know one of the answers is x equals 1. Now to solve this one, oh man, that looks hard too. So I probably want to do rational root theorem again. You could either do it again with this new one, which will give you the same list, plus or minus 1, plus or minus 2, plus or minus 11, plus or minus 22. Positive 1, if we do 1 in there, we get 0, 1, minus 1 is 0, 1. Positive 1 doesn't work. Negative 1 would be negative 1, minus 1, minus 1, minus 1, minus 1, minus 22, and that one's not going to work. Positive 2, it's easier actually, I think, on the original one to figure it out, but positive 2 would be 32 minus 16 plus 8 minus 4 plus 2 minus 22. And so this is going to be 40... 42 minus, oh wait, I got to do this math right. Okay. 40, 42, no, that's going to be 20, that's going to be minus 42. So that one's going to be 0. So positive 2 works. So then we can do another synthetic division. So this is, yeah, I'm sorry. This is a little tough, but you got to be able to deal with this. Now this time there's no missing terms. Drop this down, get 1, 2, 1, 2, 3, 6, 5, 10, 11, 22, 0. Good. That's good. Now, I don't really need to factor this anymore. This is what we've gotten so far. That should be actually positive 1. And now we have x to the 4th plus x cubed plus 3x squared plus 5x plus 11. I'm actually assuming that there's no more real answers. We just need 2, and let's just make sure these make sense. So negative 1 would be right here. And if you plug it into both functions, it should give you the same thing. So that's going to be positive 1. That's going to be, yep. Okay. And then positive 2 is right here. You plug 2 in here. You get 42. You get 20. No. Plug 2 in here. You get 42, 64. Wow, that's a big number. 64. And if you plug 2 in here, you get 64. So that's good. Now, that was definitely one of the big hard things about this. Okay. Okay. So then now for the area part. Now, there was nothing new here yet. This is actually stuff that I could have given you way back in this first couple units when we were reviewing algebra. So we're going to do dx and dy. So dx is going to be vertical slices, right? Vertical slices, y top minus y bottom. Check, make sure that y top is the same the whole time, y bottom is the same the whole time. So the area is going to be y top, which is this function, 21x plus 22, minus y bottom, which is the x to the 6 function. And we're going to go negative 1 to 2. And that's all you're asked to do. You just have to set it up. Okay, now B, a lot of people put this off. B is a little tougher, and a lot of people just totally miss this idea. Look, if you draw, and this is what I recommend you do, if you draw a horizontal slice, you should notice that at some point, the edges change the curves. Like here, you got to do this chunk different than this chunk up here, because x left changes in the middle of it. Now, we got to find, so we got to do 0 to 1 and then 1 to 64, 2 separate integrals. We have to do 0 to 1 and 1 to 64 separately. Now, we got to get this x right here, and what it's going to be is plus or minus the 6th root of y. If we solve for x, take 6th root of y plus or minus, and the plus or minus actually matters this time because this is the positive 6th root of y, and this x left over here is the negative 6th root of y because it's the left half of that parabola-looking shape. Now here, this x left, we got to solve for x, so it's going to be y minus 22 divided by 21, right? That's going to be that one. So now this first chunk, x right, is the positive 6th root of y minus negative. It wouldn't make sense for them to cancel each other out, so that should give you a bad feeling. But that's the first one. And then the next one, the positive 6th root of y is still the right side. And the left side is this, so it's 1 over 21y minus 22 over 21. And that could be it. Now, if you don't want to write these parentheses here, you got to make sure that you distribute this negative. Okay? You got to make sure you distribute that if you want it. This one we could even, so I mean, we could simplify this a little bit. We could say, oh, well, this is going to be 0 to 1 of 2 6th root of y dy, right? Plus 1 to 64 of this. So we could clean this up a bit if you want, but I wasn't asking you to. I'd be totally fine with that first answer. The only other issue that really was tough. I'm trying to find it. It was I feel like it was the mean value theorem problem. Oh, yeah. Yeah, on problem 10, which I didn't do, but there was a place where a lot of people got an answer like this. They got like +2 plus or minus 4√7 over 2 or something like that. And this is just algebra. They're doing quadratic formula. And then they did this. And then they wrote their answer was like this. That's wrong for a bunch of reasons. One, this guy needs to get divided by the 2 also. So it should be 2. Okay? The other one is 2 divided by 2 is not 0. You're essentially saying it's 0. No, it's a 1. If a fraction reduces away, it's not 0. It's 1. You have to distribute division. And if two things divide cleanly into each other, you get a 1. You don't write 0. So anyways, a lot of people did that, which is going to make your algebra teachers or even pre-algebra teachers, I guess, cry. They're going to be very sad. They will disown you, but this time, redeem yourself in the retest. That's it.